Well, good morning. It's 11:30 on the 13th. Whoa, here's Kira coming in. Let me get her here. And I'm in the wrong grade book here. So Kira is here this morning. Good deal. Still waiting on the 2 Y chromosomes. How are you doing, Kira? Good, thank you. There will be some changes today. I'm going to wait and see if some of the others do come in. So I'll explain those as they get here. Do you have any questions, issues, concerns, problems, anything? Okay. Well, then what I think I'll do, I'm already recording. I was starting to get started. I think I'll go on with the announcement first. No reason to get started on the other. Over the weekend, I don't know if you noticed it or not, that was midterm. Okay, we are now in the second half of the term. Okay, I just finished my first mini-term class last Thursday, or I thought I had finished it on Thursday. I kept getting so much late work coming in late Thursday, Friday, over the weekend, yesterday. Just it kept piling in and piling in and piling in, and I had to get it graded. I had to get it on Blackboard. I had to get grades calculated. Had to do all that stuff. So I'm behind this week getting things done as on Blackboard. I know you check your Blackboard all the time and make sure what the overviews and things like that are. I'm behind on that, so that's sad, sad song. In addition to that, I'm starting a second mini-term class today. So, and the dean said we had to have everything ready by yesterday. So when I finished doing all the stuff that I had to do for the first mini-term class, I started working on all the stuff I had to do for the second mini-term class, which starts later this afternoon. Now, the main reason I told you about the second mini-term, well, number one, it took time to get everything set up for it. But number two is it's not starting at the same time as my first mini-term class was. First mini-term class, this class ends at 12:45. It started at 1:15. So that was my half-hour lunch, okay? That's all I had, okay? And then it went until 5:45 in the evening, so then it was supper time. Well, the second mini-term class, because some of the auto mechanic students need this course to graduate, a lot of them take it in the spring, which then is at a reasonable time, but one of the majors decides to take it, they want to take it in the fall. Well, unfortunately in the fall they have classes that go until 3 o'clock. So that means I can't start my class until 3:15. So it starts at 3:15 and goes until 7:45 in the evening. So what that means is now my office hours have changed. Before, on Tuesday and Thursday, basically the only office hours I had was 8 to 8:30 in the morning, and that was it. Okay. Now I still have those, but that's not really very long, and it's also I'm trying to get ready for the day and that kind of stuff. So now my office hours on Tuesday, Thursday, since once this class is over at 12:45, I have until 3:15. So how I will post them, I'll just say 1 to 3. Okay, that gives me time to wrap up this class and time before the next class starts to get some stuff done. So I'll be listing it as 1 to 3 office hours. Now I do eat lunch sometime in that time frame, so but you can still try to contact me. Let me go into another issue before I get too much into that. Okay, so that changes office hours. So now I do have a block of office hours on Tuesday and Thursday, 1 to 3. So that augments my Monday, Wednesday, 8 to 10 and 4 to 6, Monday and Wednesday, Tuesday, Thursday, 1 to 3, and then Friday, 8 to 12. So those are my office hours for the week. Expanded because I'm going till 7:45 at night on Tuesday and Thursday evening. Okay, so that's the one change. that's for the rest of the term now. The other change, and this is just for today, I have a doctor's appointment this afternoon. I don't know what time. That's strange, but I don't. It'll be after 1 o'clock is all they said, and it's going to be a telemedicine thing. So they're either going to have me link up with something, which they did last time, but they haven't sent me anything this time, so I have a feeling it's just going to be by phone. Now, I have seen my blood work that I had done last Friday, and most things are okay. In fact, some of them are quite good. But my white cell count is basically through the roof. So that means I'm going to have a treatment probably pretty soon. I'm going to try to schedule that like I always do for Fridays so it won't interfere with classes. But that may mean, there's two things that means. One, oh, here comes James. Let me get him in here so he can hear the rest of this. So we have 2/3 of you here now. If we can just get Jesus, we'll have the full house. James, I was just telling Kira about my change in schedule. First mini-term ended last week. First mini-term starts this week. The second mini-term starts this week. My first mini-term physical science class in the afternoon started at 1:15, just 30 minutes after this one ends, and that was my lunch half hour. But it went till 5:45 because it was a mini-term class with a lab, so everything was doubled. But my second mini-term class, because some automotive students need this course, I can't start it until after 3, so it starts at 3:15. So now I have office hours basically between 1 and 3 on Tuesday and Thursday that I didn't have before. Technically they're between 12:45 and 3:15, but just to make it easier to type, I say 1 to 3 because I do close down this class and get it set up and then set up the next class. So I do need 15 minutes or so, not quite 15 minutes, but so I'll just say 1 to 3. So that will be a change. I don't have it out there on Blackboard yet, but I will be doing it sometime this week, hopefully. Okay, that also means I go until 7:45 Tuesday and Thursday evening, which is not such good news, but at least it gives me some office hours in the middle of the day to do things. Now, the thing about today, though, I have a doctor's appointment this afternoon sometime after 1. That's all they told us, is sometimes after 1 o'clock. And so I won't be available during all those office hours today. It's a telemedicine appointment, but I know it'll last at least 15 minutes and maybe 30 minutes or longer. But I do know that he's going to want to schedule me a treatment because I did the blood work last Friday. I got the results and the white counts are through the roof. The rest of everything looks okay, except for how the white counts have affected other things, but that's to be expected. But I know that some Friday coming up, I will not be in my office hours that day either because I'll have to be at the Kirkland Clinic for a treatment. At least that's my guess right now. So those are the changes that are happening now. So right now my office hours will be Monday and Wednesday, as it always has been, 8 to 10 and 4 to 6. Tuesday, Thursday, new office hours 1 to 3. And Friday, as it has always been, 8 to 12. With the exception that at least one Friday I will have to be at the Kirkland Clinic for a treatment. So, do y'all have any questions, issues, concerns, problems that you want to bring up before we get into class today? Okay. I haven't said this every time, I admit to, but I haven't. I hope that you're registered to vote. I think registration for this coming election ends sometime this week. So please try to get registered if you're not. And if you are registered, please vote. My wife and I have already voted. We went down one Friday afternoon and voted, and that went really smoothly. We went to the courthouse and voted. You can also do an absentee ballot, that they mail you, but then you have to get notarized and everything like this. It's so easy to do it in the at the courthouse. It took us about an hour because we had to wait in line, but they say record numbers of people are voting early, which is fantastic. That way I don't have to go out in November in the weather, and especially if my health situation isn't the best and with COVID going around, it was much easier. In the courthouse, they keep you well spaced. You're masked all the time, so everything works well. But please vote, folks. We've got to. Okay. All right. Any questions, issues, concerns, problems? Okay. Let me get the screen share set up. And we're doing from the whiteboard, of course. And I've got to move some things around. Get the Zoom's taskbar out of the way. And get the whiteboard taskbar out of the way. And get the two of you slightly out of the way, me too. Okay. Oh, and here comes Miguel today, or Jesus. Perfect attendance. Ding, 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 ding. Okay. All right. Jesus, you're in here now. I was just telling the others, we have now entered the second half of the term. Basically, another way to look at it, my last half of a term teaching, because I'll be retiring in February, 1st of February. I do have a change of office hours because my first mini-term physical science class started just 30 minutes after this one was over with. So there was my lunch half hour between 12:45 and 1:15. The second mini-term class, some of the automotive students need it, so I can't start it until 3:15. So now I have office hours on Tuesday and Thursday from 1 to 3 in the afternoon. Didn't have those before, now I do. The bad news is I go until 7:45 at night, so don't try to catch me on Tuesday, Thursday evening before 8 o'clock. Okay, and even then I'll be eating supper sometime in there. But most of you don't call that late at night anyway, but that's my schedule. Now, the other thing is today I have a doctor's appointment. It's a telemedicine appointment, so it'll just be by phone sometime after 1 o'clock, and it will be I'm pretty sure he's going to, I've seen my lab results that I had done last Friday, and I'm almost certain that he'll be scheduling me for a treatment one Friday coming up pretty soon because my white counts are really high. So anyway, that's got to happen. So one Friday I'll be out of pocket. I don't know which Friday yet, but I'll let you know as soon as I know. It could be this Friday. I don't think they can schedule me that soon, but it could be. So if you can't catch me on Friday, that's probably the reason. The Kirkland Clinic is really hard to get a good signal in there, so I can't do too much. I can grade papers from there, but I can't do much else, email or anything else, most of the time. Occasionally I can get through, but most of the time all the metal around and the electronics around, it's just really lousy on signals. All right, any questions, issues, concerns, problems? Okay. Now, where we are is in Chapter 2, Matrices, Section 2.4, Elementary Matrices, and we're on page 75, the C part of Example 2. We did the A and B part last time. I think all of you were here then too. So unless there's some question or issue, we'll pick up with 2C just about the middle of page 75. Now, here they show us a matrix. This matrix is 1, 0, 0, 2, 1, 0, 0, 0, 1. Is that any kind of special matrix? You tell me. Anybody? Not the one I'm writing now, the one I've already written. No takers on it, huh? Now that is a really ugly 2. If I've ever seen an ugly 2 before, that's one of them. Okay, so let me see if I can get that to look a little bit better. There, that's a lot better. Okay, can anyone tell me this? I'm just going to name matrix A because they name it matrix A. What is this matrix over here? Anyone have a clue? Anything special about it? What if I said in the book they name it E? Would that mean anything to you? Sorry about that. I accidentally pressed a button that has nothing to do with anything here, so let me see if I can get that to go away. Anybody? What does E stand for? What's the name of this section? I've said it a couple times. Elementary matrix. E is an elementary matrix. What makes E an elementary matrix? It's one elementary row operation away from an identity matrix. The identity matrix, 3 by 3 identity matrix, 1 0 0 0 1 0 0 0 1. Remember our 3 elementary row operations? Exchange any 2 rows. That's not what we've done here. Multiply a non-zero number or divide a non-zero number, any row by a non-zero number. That's not what we've done here. Or the third one, adding a multiple of one row to another row. Yes, we did that. 2 times row 1 plus row 2 of your identity matrix would produce this new row 2. One single elementary row operation, that's it. So we're going to multiply these 2 matrices together. This is a 3 by 3. This is a 3 by 3. We can certainly multiply them because the middle 2 numbers are the same, and that will produce what the leftover numbers are, which is a 3 by 3. So that means you have 3 columns and 3 rows. To do the 1 1 entry here, first row, first column, do the first row of E, first column of A. 1 times 1 is 1, plus 0 plus 0. That's just a 1. The 1 2 entry here, first row, second column will be first row of E, second column of A. That would be a 0 plus 0 plus 0. That's a 0. The 1 3 entry here will be the first row of E times the third column of A. Negative 1 plus 0 plus 0 is a minus 1. Done. The 2 1 entry here, second row, first column, second row of E, first column of A, 2 minus 2 is 0, plus 0 is 0. Interesting. The 2 2 entry here, second row of E times the second column of A 0 minus 2, 0. So that's just a minus 2. Okay. The 2 3 entry here, second row, third column, second row here, third column there, would be a minus 2 plus 3 would be 1. So that's just going to be a 1. Okay, I've got an itchy nose. I don't know why. Must be going to have company. All right, the 3 1 entry here, third row, first column, third row here, first column there, would be a 0 plus a 0 plus a 0. Okay, your 3-2 entry here, third row, second column, third row here, second column here, 0 plus 0 plus 4. And then finally your 3-3 entry here, third row, third column, 0 plus 0, 5. Now, what has that done for you? Okay, well, here's what it did for you. You took matrix A and did the same elementary row operation you did on the identity matrix, multiplying 2 times the first row, adding it to the second row. That's what you got here. 2 times 1 is 2, plus 2 is 0. Notice row 1, row 3 are exactly the same. Row 2 has changed. How did it change? 2 times 1 is 2, plus, minus 2 is 0. 2 times 0 is 0. Minus 2 is minus 2. And 2 times minus 1 is minus 2, plus 3 is plus 1. That's what you did. So basically that elementary matrix E here, if I could find it, there it is, did the same elementary row operation to matrix A as what it had done to it to come into being from the identity matrix to the elementary matrix. Now, is that supposed to be easier than doing just the elementary row operation here? No, no way. It's more involved, but it does the same thing. Okay, so why are we doing this? Well, let's take a look in the book. It says, notice from example 2b, that's the one we did last time, that you can use a matrix multiplication to perform elementary row operations on non-square matrices. A and C were both on square matrices, which are fine. It does them on non-square matrices too. It just has to be the right size of an elementary matrix. All your elementary matrices, because they came from an identity matrix, they have to be square. Okay? So if the size of A is n by p, any n by p, E has to be order n by n, so you can multiply it, and then the answer will still be n by p. Okay. Now, each of those three products in example 2, you were able to perform the elementary row operations by multiplying on the left by an elementary matrix. The next theorem, stated without proof, generalizes that property of elementary matrices. Now, I think I will type this one in just because it's a long thing to write, and I'm dropping my pen, and it's an expensive pen. I don't want to damage it. So let me type this in text. I think I'll do it on this slide. We got room, I think. Okay. Let E be the elementary matrix obtained by performing an elementary row operation on some identity matrix I. I can't do a subscript, so that IM stands for I sub M. Okay. If that same elementary row operation is performed on an M by N matrix A, then the resulting matrix is the product EA. Okay. Only multiplying the elementary matrix on the left by the by that matrix you're doing the elementary row operation on. And again, you'll say, why do that if it's more complicated than just doing the elementary row operation? We'll get to that. That's coming up. Most applications of elementary row operations require a sequence of operations. For instance, Gaussian elimination usually requires several elementary row operations to reduce a matrix. This translates into multiplication on the left by several different elementary matrices. The order of the multiplication is important. The elementary matrix immediately to the left of A corresponds to the row operation performed first. Okay, and this will show example 3. Now, this will definitely take a whole page. Okay, so what I'm going to do is clear the screen. Any questions on this before I clear it? Any whatsoever? Okay. Now, let me write down, remember what I did with my pen. Write down, it says find a sequence of elementary matrices that can be used to write matrix A in row echelon form. So here's matrix A. Whoa, that's not what I wanted. Okay. Okay. Here's matrix A. I went to draw, and when I went to draw, nothing happened. So here's matrix A. Zero, 1, 3, 5, 1, -3, 0, 2, 2, -6, 2, 0. Okay. Not a square matrix, it doesn't have to be. But what it means, your elementary matrices have to be square. Okay? And they're going to be multiplying on the left, so that means it will need to be order 3, because you have 3 rows here, and since you're multiplying on the left, you'll have to have a 3 by 3 by 3 by 4 to give you a 3 by 4. All right. Now what I'm going to do, the book doesn't do this, but I do it. I write my I3 up here. Okay? Just for reference. Okay? We don't really need to, but I like to do it. 1, 0, 0, 0, 1, 0, and 0, 0, 1. We're certainly not going to multiply that by anything, because that wouldn't produce anything new. It would just reproduce whatever you multiply by, as long as it's the right size. Okay. Now, if you were trying to row reduce matrix A here, what would be your first move? What do you want to be the first step in the row reduction there? What do you want where? Don't you want a 1 in the upper left? Of course you do. That's how we always begin. How could you accomplish this? Now I can think of 2 ways, but I know what the book's going to do, and the way I would do it too is just exchange these 2 rows. Okay? Now if you exchange those 2 rows, what do you get? That would be 1, -3. Yuck! This pen is doing such weird things. Okay, let me start that one over again. Okay, 1, -3. If I write too fast, it screws up. 0, 2. Exchanging those 2 rows. 0, 1, 3, 5. Now, if I were doing this, I would take that last row and divide by 2. But they're not doing it, so let's carry it on. 2, -6. I don't see any reason to write down bigger numbers than you have to. Okay, now that was the row operation we did, elementary row operation, to get that 1 up there. Well, what elementary matrix happens because of that same thing, exchanging the top 2 rows? The E1, they're going to call it, that does that operation is going to be exchange the first 2 rows of I. 0, 1, 0, 1, 0, 0, 0, 0, 1. That's E1. The first, this elementary matrix would have done that same thing to that one. Okay, what's the next thing you want to happen? Well, you got a 1 here, you got a 0 there. We're happy with that. We want that to be a 0, so you're going to do -2 row 1 plus row 3. And that's going to be the new row 3. So that's going to be 1, -3, 0, 2. This will stay 0, 1, 3, 5. And the new row 3 would be a 0. -2 times -3 is 6. But whoa, look at that. That goes to 0. -2 times 0 is 0, plus 2 is 2. And -2 times 2 is -4, plus 0 is -4. Okay. Now, what elementary matrix would do that same thing? Now, notice here, don't get confused. We're not using this elementary matrix, you're using I. That's why I wrote it here. That you do this to I. -2 row 1 plus row 3. I didn't write it, yuck, row 3. I didn't write it before, but we exchanged the 2 rows here, and that's what we did here. So this will be, this top row stays the same, 1, 0, 0. We're doing this one now, I, not E, okay? Second row stays the same, 0, 1, 0, that second row. And then -2 times row 1 added to row 3. That's what we did here. That's what we're doing here. That would give us a -2, 0, 1. That's your second elementary matrix. Okay? What's next? Now, we're doing Gauss-Jordan or just Gaussian? We're just doing Gaussian elimination. Okay? So the next one, all we want to happen, you got for Gaussian elimination, you want a 1 here, 0's below it. Get out of there. Okay? 1 here, 0's below it. Leading non-zero entry here is a 1, 0 below it. We already got that. All you need is a leading 1 here. All we do is row 3 divided by 2. And that will give you a 1 there. Now I'm going to come up here and erase this because we're not using that anymore. We've already done that. Been there, done that, and bought a t-shirt. Okay. What we'll have down here, top row stays the same, 1, -3, 0, 2. Second row stays the same, 0, 1, 3, 5. Third row becomes a 0, 0, 1, -2. Okay, so this E3 here, remember, you do it to the I matrix, the identity matrix here, divide row 3 by 2. That's all you're doing. So this will be, row 1 stays the same, 1, 0, 0. Row 2 stays the same, 0, 1, 0. And row 3 gets divided by 2, 0, 0, 1/2. Now, there's your 3 elementary row operations, elementary matrices that did the same thing as the elementary row operations did there in your Gaussian elimination. Now, And they go through all this, and I guess I'll do it too. Okay, it's somewhat of a pain in the neck, but it's doable, and it's not that bad, actually. If you were to take your matrix A, here's what we're going to do. We want to show that this is true. That matrix B, which we don't, well, this is going to be B down here. They didn't tell you that yet, but this is matrix B. Okay, that matrix B is indeed, now you do them in reverse order. Oops, I'm sorry, I didn't mean to do that. E3 times E2 times E1 times A. The order that you did them. This one first, this one next, this one next. Okay? The order matters here. Okay? So let's see what we get here. This is somewhat of a pain. I'm going to start with these two here on this end. E1 times A. And since I got E1 right here, I'm going to multiply that by A. And A was 0, 1, 3, 5, 1, negative 3, 0, 2, and 2, negative 6, 2, 0. I'm trying to write it cramped together because, okay, this is a 3 by 3 times a 3 by 4. That's going to give us a 3 by 4. Goodness, my stomach is growling. Sorry about that, folks. I don't know if you can hear it or not, but I sure could. Okay. Now, we do it in this order, so multiply the first row, first column. That's a 0 plus 1 plus 0, so that gives us a 1 here. Okay. First row, second column, a 0 minus 3, 0. So that's a minus 3. The first row, third column, 0, 0, 0. Okay. And the first row, fourth column, 0, 2, 0. That's just a 2. So pretty easy multiplication to do because you got pretty simple numbers that you're dealing with. Okay. Second row, first column, a 0, 0, 0. That's just going to be a 0. Okay. Second row, second column, 1, 0, 0. That's just going to be a 1. Second row, third column, a 3, 0, 0. That's just going to be a 3. And then the fourth column, a 1, 2, 4 is going to be 5, 0, 0. That's a 5. Okay. And then the third row, first column is going to be a 0, 0, 2, a 0, 0, minus 6, a 0, 0, 2, and a 0, 0, 0. Okay. And sure enough, this is exactly what you get here. Okay. Now, we're going to take that and multiply it by E2 because the product of these two is this one. Okay, is that one. And so we're going to take that and multiply it by E2 here. So this is going to be 1, negative 3, 0, 2, if I can read my writing, 0, 1, 3, 5, 2, negative 6, 2, 0. If you multiply those two together, you should get a 1 by 4. Okay, running out of room here. This will be, where's my pen? Come on, pen, show up somewhere here. There we go. A 1, 0, 0, that's just going to be a 1. A minus 3, 0, 0 is going to be a minus 3. A 0, 0, 0 is going to be a 0. And a 2, 0, 0 is going to be a 2. Okay. Next one, a 0, 0, 0 is going to be a 0. Goodness, I'm going to have to get something to drink between my stomach rolling and stuff. Hunger is setting in. I shouldn't have been talking about getting to eat a full lunch today. I'm so sorry to have to do that, but it's going to be hard to concentrate without it. Okay, so the 2 entry 0, 1, 0, that would be a 1. 2, 3 entry 0, 3, 0, that's a 3. And the 2, 4 entry 0, 5, 0, that's 5. And then the 3, 1 entry, negative 2, 0, plus 2, that goes to 0. Excuse me. Negative 2 times negative 3 is positive 6, plus 0 minus 6 is 0. A negative 2 plus 0 plus 2, no, I'm sorry, that's a 0 times a, let's see, 3 entry, 0, 0, 2. And then the 3, 4 entry is a minus 4, 0, 0. That's a minus 4. And believe it or not, that's the same thing we got here. Exactly the same. And that then is the product of these three. Those two, the product of those two times this one. So now all we have to do is multiply by E3, and we'll do this one here, 1, negative 3, 0, 2, 0, 1, 3, 5, 0, 0, 2, negative 4. Why the 5 hat didn't show up, I don't know. And I don't have much room here. This is going to be really crowded. Okay. This will be a 1 times 1 is 1, plus 0 is 0. That's a 1. A negative 3, 0, 0 is a negative 3. A 0, 0, 0 is a 0. And a 2, 0, 0 is a 2. All right. 2, second row, various columns. That would be a 0, 0, 0. That's a 0. A 0, 1, 0. That's a 1. A 0, 3, 0. That's a 3. And a 0, 5, 0. That's a 5. All right, now the third row times the various columns. A 0, 0, 0, that's a 0. A 0, 0, 0, that's a 0. And then the 3, 3 is a 0, 0, and 1/2 of 2 is 1. And then the 3, 4 is going to be a 0, 0, and 1/2 of -4 is -2. And that, sure enough, is B. Same B as we have over here. So yes, that series of elementary row multiplications gives you the same result as the series of elementary row operations, okay, which we had shown before and they just showed us again. Okay, so we got there. Now, those two matrices, A up here and B down here or over here, whichever one you want, those are row equivalent matrices, okay, because you can obtain B by performing a sequence of row operations on A, but it's also because you can get B from a series of multiplications of elementary matrices times A. So this then gives us a new definition, and I think I'll clear the screen. Try to clear the screen. Why won't the screen clear? I'm hitting the wrong button, that's why. Okay, so let's do another definition of row equivalence. We'll do this in a text, and I can't do subscripts and superscript type thing, but we'll do what we can. Let A and B be M by N matrices. Matrix B is row equivalent to A when there exists a finite number, too many I's in there, of elementary matrices well, not enough E's in that one. E sub 1, I can't do my subscripts here. E sub 2, E sub 3, dot, dot, no, those are not dots, those are commas, dot, 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 all the way down to E sub k. I can't do a subscript, so that's supposed to be there, such that the new matrix B is equal to the reverse order of those, E sub k times E sub, and this is going to be really bad, k minus 1, that's all subscripted, that's not a 1, that's an A, okay, E sub k minus 2, this is really ugly, I wish I hadn't done this now, okay, times dot, 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 all the way down to E sub 3, E sub 2, times E sub 1. Those are all supposed to be subscripts there, times A. Well, it's supposed to be an A. Okay. Now, let's string this out. Okay, so A and B are same size matrices, M by N. They don't have to be square. Matrix B is row equivalent to A when there exists a finite number of elementary matrices, E1, E2, E3, E4, E5, all the way up to E sub k, finite number, such that B now is the E sub k times E sub k minus 1 times E sub k minus 2, dot, 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 all the way down to E sub 3 times E sub 2 times E sub 1, and finally multiply that by A. That makes B row equivalent to A. If there's a finite number of elementary matrices you can do. Now it says you know from section 2.3 that not all square matrices are invertible. We knew that. Every elementary matrix, however, is invertible. Moreover, the inverse of an elementary matrix is itself an elementary matrix. Okay, so there's the next little theorem we'll do. Okay, if E is an elementary matrix, then E inverse. Now I can't do the superscripts either, so that's supposed to be inverse of E, exists and is an elementary matrix. So number one, elementary matrices are invertible. They're square for sure, and they are invertible. E inverse does exist, and it itself is also an elementary matrix. Okay, now let me string that out. Okay, whoops, too much. Okay, now the inverse of an elementary matrix, E, is the elementary matrix that converts E back to I sub n. For instance, the inverses of these three elementary matrices in example 3 are shown below. Now we already did those. I've had to erase them, but I'll show you what they are. Okay, from before, let's go to our draw mode here. Okay, let me get my drawing pen here. Okay, here was that first elementary matrix we had, E1. It was 0, 1, 0. If you have your notes, you can see this. 1, 0, 0, because we got it by interchanging the first two rows, 0, 0, 1. Okay, so what is its inverse matrix? E inverse. E sub 1 inverse. Okay, now what would change that back to an identity matrix? Exchange those same two rows. So that would be 0, 1, 0, 1, 0, 0, 0, 0, 1. Because if you were to multiply those by each other, you are you're exchanging the two rows of this one to get back to the elementary matrix. Where's the, yeah, that one. So that's what you do here. The inverse matrix is exactly the same. Okay, for exchanging two rows, they're exactly the same. Now the second elementary matrix we used in the last example, E sub 2, if you recall, was this one. 1, 0, 0, 0, 1, 0, but we multiply the first one by 2 and added it to the third, 2, 0, 1. Okay, or that was a minus 2, sorry, I forgot. Okay, now what would be the inverse matrix of that one? what operation would you do to that one to get you back to the identity matrix? Okay. Where's my, okay. What would you do? Well, multiply the top row by 2 and add it to the third row. Well, the elementary matrix that does that would be 1, 0, 0, 0, 1, 0, 2, 0, 1. That would be the one that undoes that one. And that sure enough is. The third elementary matrix that we had in the last example was, if I'm not mistaken, 1, 0, 0, 0, 1, 0, 0, 0, 1 half, because we took 1 half of the third row. Okay? Well, what would be its inverse matrix? What would you do to this matrix to make it become an identity matrix? Multiply the bottom row by 2. So that then would be 1, 0, 0, 0, 1, 0, 0, 0, 2. Its inverse matrix would do the opposite. Okay? Does that make sense? Okay. You can use matrix multiplications to check those results to see that multiplying those two together, you get the identity matrix in every case. All right. Now it comes time for another theorem. Okay. Yeah. Okay. I was just trying to keep track of my time here. And I think what we'll have to do is go to a clean page, because I don't think I'll allow enough room otherwise. So here will be the next theorem. A square matrix, oh, let me get my text box set up. Okay, a square matrix A is invertible if and only if, I wish I could do my symbol, but I can't, so I have to type it out. If and only if it can be written as the product of elementary matrices. That's a pretty broad statement, isn't it? A square matrix A is invertible if and only if it can be written as the product of elementary matrices. That's it. Okay? Now they do a little proof here, and there's a lot of verbiage in it, so I'll let you read the verbiage at your leisure. Let's go to example 4. Okay? I think we have time for this one. Okay? And let's see if can we get it on this page. Maybe not. I mean, not much on here, but let's go to a clean page. Can I erase this one? Okay. Now, here's matrix A. Thank goodness they gave us a pretty simple one. Okay. I got to get back to my draw mode. Okay. Here's matrix A, 2 by 2, -1, -2, 3, 8. Okay. Now, number 1, it's a square matrix, obviously. Now, With a 2 by 2, you can basically look at it and know that whether it's invertible or not, or non-singular or singular, however you want to say this. And this one is invertible, meaning a non-singular matrix. The reason is no row is a multiple of the other row. Okay, so, and no column is a multiple of another column. They both work hand in hand. Okay, so if you want to find the sequence of elementary row operations that can be used to rewrite A in reduced row echelon form. Now that's the same thing we did before, almost. What we did before was find matrix B, okay? What we want to do now is to rewrite A in reduced row echelon form, okay? Which basically is coming up with B, okay? All right, now I'm going to again put my I matrix up here. You don't have to, and this is I sub 2 because that's a 2 by 2. 1 0 0 1. But I'm going to do something different this time. I'm not only just going to write E, I'm going to write E inverse as well. Now they don't do it in the book, but I'm going to do it. Okay, now what's the first thing we would do to A to get it into row echelon form? Okay, multiply the top row by minus 1. Minus row 1. Okay, so that would then be, I'll just do this, that would produce the matrix 1 2 3 8. Well, the elementary matrix that did the same thing, that's a really ugly writing, okay, that did the same thing, was that would be E1 would then be minus 1 0 0 1. Now, what would be the inverse matrix of that? E1 inverse. To get back to the identity matrix, you do the same thing. Multiply the top row by minus 1, and you will get back to I. Okay? So, next thing you would do is minus 3 times row, I'm writing this in the wrong place, 1 added to row 3. It should have been down here. Okay? That would be a 1 2 0 2. Negative 3 times 2 is negative 6 plus 8 is 2. Okay? Now the E2 that does that would be same type thing here, but go up here to the identity matrix. Minus 3 times row 1 added to row 3. That's not row 3, that's row 2. Only the 2 by 2 matrix can't have a third row. Okay? Top row stays the same, 1 0. The bottom row becomes negative 3 1. Okay. Now, what's the E2 inverse? That would be 1 0. To get this back to that, you would have to 3 times the top row to the second row, and that would be 3 0. Okay, there's E2 inverse. There's E2. This is E2 inverse. Now, next thing we want to do is row 2 divided by 2. Row 2 divided by 2. Okay, and that would produce 1 2 0 1. So the elementary matrix 3 that does that same thing is row 2 divided by 2, that would be 1, 0, 0, 1/2. Also multiplying by 1/2 is the same. Okay, what would be your inverse matrix of that? E3, inverse. What we do to this to get back to the identity matrix? Multiply the second row by 2. So that would be 1, 0, 0, 2. Okay, now we're doing reduced row echelon form. Yes, reduced row echelon form. So the one last thing that we've got to do is minus 2 times row 2 and add it to row 1. Okay, that I think will do it for us. Row 2 will stay at 0, 1, and row 1 will be 1 minus 2 times that, 0. Okay, so now we've produced an identity matrix here. Well, what elementary matrix would have done that same thing? Remember, you're using the I matrix, identity matrix to be minus 2 times row 1, row 2 added to row 1. So that would have been a 1 minus 2, 0, 1. What would have been the inverse of that? Goodness, am I hungry? I can't stand this. Okay. Goodness, it's so hard to concentrate. I'm going to eat me an almond. Maybe that will help. I'm going to crunch. I'm sorry about that. Okay. What would you do to this to get back to identity matrix? Multiply the bottom row by 2 and add to the top. So that would be a 1, 2, 0, 1. So these are our 4. That's a 4 here. Where in the world did the 3 come from? I don't know. Okay, so those are our 4 matrices. Now, here's the interesting thing. If we wanted to get matrix A, not its inverse, but matrix A, you can get A by multiplying just these 4 inverse elementary matrices, which themselves are elementary matrices together, but in reverse of the reverse order, okay? Because you see, you multiplied this times this on the left, then you multiply this by that on the left. Okay, so basically what you did, you started with A and multiplied by E1, then by E2 on the left, then by E3, and then by E4. And when you did that, you got the I. You got the identity matrix here because you were doing row reduction. Well, if you would then turn this around and multiply this by E4 inverse, I can't get the minus sign to write, and then it quits writing. It drives me nuts. Okay, I'll leave it like that. Okay, E4 inverse, then multiply, because that becomes the identity matrix, then multiply by E3 inverse, okay, then multiply by E2 inverse, and then multiply by E1 inverse. If you were to do all that, you come back to A again. So basically, these multiplied together gave you I, And if the answer gives you A, then these multiplied together gives you A. So that would be E1 inverse times E2 inverse times E3 inverse times E4 inverse. And that's how you get matrix A from a product of elementary matrices. From the inverse matrices in reverse order from the ones that gave you the row reduction. Okay, now do we have time to show that? Let's see if we can. Let's do this one times this one. Okay, now this is done vertically. I usually do it horizontally, so I may make a mistake here. First row by first column, that would be a -1. First row by second column. Now whatever I wrote here was wrong. Sorry about that. Y'all didn't catch me. What are y'all doing? Okay. That's a 1 there. Okay. Not a 0. Okay. Okay. First row by second column here gives us a 0, 0. And second row by first column gives us a 3. And second row by second column gives us a 1. Okay. Take that product and multiply by this one. And that gives us first row by first column a -1. First row by second column gives you a 0, I think. Again, I'm not doing, wait. First row, no, this first row by that second column. Yeah. And then second row here by first column there is a 3. And second row here by second column here gives you a 2, I think. Okay, then let's multiply these two together. Will be a 2 by 2. Okay, and this will be first row by first column is a -1. First row by second column is a 4, I think. No. Okay, I think I've gotten lost in the sauce here because I'm used to doing them horizontally and these are vertically, and I'm probably messing up. And we're running out of time. Okay, first row. Okay, that was right. First row by second column. That's a -2 plus 0. That's a -2. Good. Okay. Second row, first column. That's the 3. Second row, second column. That's a 6 plus 2 is 8. Yes, sirree, Bob. That gave us our A. So sure enough, A can be derived from the inverse elementary matrices that you would use to get A to produce a row reduced down to an identity matrix. Okay, the elementary matrices that you would have used to make that happen do the inverses of those elementary matrices, multiply them together, and you get A. All right, I think we are now out of time. Sorry about that, but it was a fun day, wasn't it? Okay, so we will be beginning next time at the theorem 2-5 at the bottom of the page. Okay, 2-15, sorry, at the bottom of the page. Didn't quite make it to the top of the next page. Okay, so homework exercises here would be, this is sort of a long section here. Any of the odds 1 through 7, they're all at Calc Chat. 9 or 11 are at Calc Chat. 13 through 17 are at Calc Chat. 19 through 23 are at Calc Chat. 25 or 27 are at Calc Chat. And then 29 through 35 should be at Calc Chat. We'll stop there, pick up the rest of those next time. Any questions? Okay, did go a minute over, but there'll be no extra charge today. Okay, now if you do try to get in touch with me in the next, say, hour or so, I'm maybe tied up with a doctor's appointment, but at 3:15 I'm out of pocket again teaching a class. So but from now on, from the time this class is over till 3:15, we've got plenty of time. If you need, this is one and only time that you've had the opportunity. So if there are no more questions, I'm going to stop the sharing. And if you have no questions now, I will end the meeting for all of us. Take care. I'll see all of you tomorrow, I hope. Take care. Bye-bye.